So I will explain everything as it is. Yeah, on the center, I have a BLDC motor that is driving the whole system. As you can see, these are the wire coming out from the BLDC motor. These are the wires. So the BLDC motor has its own driver inside the motor. Look at it. It's a 208 watts BLDC motor. Now, the circle around it is the rotor. It acts like a flywheel, yet it carries the magnet. It carries neodymium magnet N52, about 12 of them. Then I have these coils around it, surrounding it. You can see 2 by 9. The two are in U core. The core is U shape. So the winding is the I think the gauge is around 0.01, about around 0.1 mm. That's the possible, the last possible fine copper wire that you can work with manually. So you wind it to get 160, around 160 ohms resistance on each of the winding. So as you can see, you have two winding on each of the U. So each of the U will give you 160 ohm resistance. Meanwhile, you know you are going to wind it. When you get to the second one in the U, you will reverse the winding so that you have it in series. Have you seen it? So it's a three-phase. It's like a three-phase motor, but yeah. So each of the phase goes through this transformer, this toroidal transformer. You can see it. This is 1, this is 2, and that is 3. That's it. That's how the advantage of this type of winding, that is the U-core winding, is that it reduces Lenz's law to the minimal, so that there is no, the coil, the magnets cannot, go back, because it is a U shape. So, and it's bringing it together at the back of it, at the corner of the U. So that's why you take advantage of that Lenz's law that is not that has been set aside, to make free energy. You see, you put when we say free energy, it means what we put inside physically is far less than what we get out of it. We are going to demonstrate it. We are going to do the testing. I have here I have let me see. Okay, I have an adapter there that we're going to use. It's a Dell laptop, an old Dell laptop adapter. It's been connected to the wall socket. I've not on it. In a short while, I'm going to connect it, and I will on it so that you see it running. You see it running, and I will also measure the amp taken by the system from the adapter. Adapter is giving us 19 volts at 3.5. It's rated at 3.5 amps, but it can take more than that if the system demands for it. However, we are going to use a multimeter to measure the amp that is being taken by the system. On a no load, we are going to measure it. Then we'll now come and add some load. I have this car headlamp there that is 60 watt. I have two of them, which is 120 watt. And I have an LED strip over there. So I'm going to test them. When I connect the load, I will also test the amp that is taken. Then we will now see the differences, what is taken and what is given out. So in a short while, I will do that. Meanwhile, if you have a suggestion, use the comments below. And in short, it is good you let me know that you are here. So just don't just jump and start asking questions. Let me know you are here by click the like button if you like this video. You can do this thing on your own. So I'm not doing it for sale because a lot of the manual, people don't read manual these days. So I don't know how I'm going to do the manual for you to understand it. So if you want to do this thing on your own, it's very simple. If you find anything, any if you need any assistance, you can call upon me. I offer an online instruction, practical instruction. I can aid you to do this stuff and many other stuff by yourself. So help yourself and become independent. Let's the grid is overstressed. That's why we're having the issue we're having the other time. So now let's do something on our own individually and help the grid to survive and serve others that are in dear need of it. So now in the next clip, I'm going to connect the system so that we'll see. So I have now connected the system. I will on it in a short while. So I connected it in series with my multimeter. The amp reading of my multimeter is in series with the positive arm of the output of the adapter. You can see, I don't know if you can see it from there. So it's in series with it. So that if I on it, you see the amperage that is being consumed here while this thing is running. So now I'm going to on it. Let's go on it. It's on. So you have to hold it. So it will start now. It started. This one. So let me connect the gallery. It's carrying two of this now, this, and it's 0.8. See, 0.8. 0.8. So as it is now, what it means is the output from that one phase, we are using single phase for the car head, the two car headlamp, and another single phase for the LED. This phase is still dormant, it's not being used, so it's 0.83, as you can see, that is being consumed. So now what it means is that even this one phase, you can use it to charge two batteries. Look at, that's 120 watts there. That's 120 watts. These two bulbs, 120 watts. You can use it to charge two batteries. So if we connect two of the phases in series, you can use it to charge 48 volt battery. Then you still have one phase left. So this is it. You don't need to complain. I think you see it. 0.83 amp. You can go all day. Nothing is heating up. No temperature issue. None. 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 Normal temperature as it is. And the motor is working on its own. Gently.